Hello, welcome to our ninth video on differentiation, and today we're going to be going over some strategies for attacking multiple choice slope field problems like the one shown to the left. So the majority of the time, the slope field problems that you'll see on the AP exam are going to be a multiple choice question, and these are usually, in my opinion, the hardest variant of whatever they can ask you about slope fields. So it's a good idea to have a general sense of how to attack these. So I'm going to share a few tips later, but right now I want you to understand that the main goal of this is to eliminate incorrect answers. So all the things that I'm going to be sharing next will help you eliminate incorrect answers, and they will never help you to point you to a correct answer. So this is a general testing strategy, but especially for these types of questions, you're going to want to pick answers that are not wrong instead of objectively, correct. So first step, whenever you are looking at answer choices for these types of multiple choice questions, factor it out if it's possible. And the reason being, we'll cover this very soon, but basically it allows you to see where the derivative will be zero a little bit faster. So factor, this is basic pre-calculus stuff. Here's some examples that I've pulled from exam questions. And the next thing you want to look at is where the derivative equals zero. So you're going to want to plug in an x or y value and see if each choice forces dy dx to equal zero. And this is why we want to factor when we're writing out the answer choices on paper, so that we can quickly see whether it's going to be zero or not. So for example, the one I have on this slide is, if you know that dy dx is 0 when x is 1, then you have to eliminate any answer choices that don't guarantee this. So maybe some choices for dy dx that would guarantee that dy dx is 0 and x is 1 include these three that I've listed below. And you can eliminate any other choices, like if you've got a xy, for example, if that was your dy dx, then that doesn't guarantee that dy dx is 0 and x is 1, so you can safely eliminate that answer choice. Now, the next thing you're going to want to look at is variable dependency. And so this is a very fancy way of saying, what variable should be in your equation for dy dx. So if your slope is changing as x is changing, right, so in the horizontal direction, then that means that your equation for dy dx should contain the letter x in it, right? And the same thing for y, except now you're going vertically. And this is important because, right, the slope field may or may not depend on both x and y. Here are three examples that sort of illustrate this point. The one to the very left, right, it's dependent on both x and y, right, because if you look horizontally, it's changing, and if you look vertically, it's also changing. And it's also important to check multiple rows or columns. Like if you're looking at the very left example, right, if you're only checking y equals 0, for instance, if you're just checking that horizontal line, then the slope is not changing. But you can't jump to the conclusion that, oh, that means dy dx isn't dependent on y, because maybe it just happens to be 0 right there. So you still have a y involved, but it's just at that line y equals 0, you're not changing. And then, we've got some other examples to the right here. So this middle one, it's only dependent on x, because if you're looking horizontally, the slope is changing, but vertically it's not changing at all. And then likewise, you've got only dependent on y. So that means if you know that a certain slope field is only dependent on x or y or both, you can safely eliminate answer choices that don't match this variable dependency that the slope field should have. And then the last thing that will probably take you to the correct answer, like 99.99% of the time, is quadrant check. So what this is you're checking the sign of dy dx in various quadrants, and you can do this with like some sort of symbolic arithmetic. I will be doing an application. I'll be applying these strategies in the next video. And you can do this with either like some sort of like symbolic arithmetic, or you can plug in points in that quadrant if you want. And if the derivative is positive or consistently positive or negative in a certain quadrant, then its equation should also guarantee that it's positive or negative. So I recommend good places to check right away are quadrants 2 and 4. And those are the upper left and lower right quadrants, if you're not familiar with the quadrant system. And the reason is that x and y have different signs there. So typically, just at least for the problems that are on the AP exam, those will typically expose the wrong answers. And help you narrow it down a little bit faster. But you still have to make sure that dy dx is consistent in the quadrant you want to check. As we'll see in the next video, sometimes the sign of dy dx can be both positive and negative in one quadrant, in which case you won't want to check a point in that quadrant because it's not consistent. And one of the most common ways that the sign of dy dx is sort of forced is with this even and odd powers thing that I've mentioned on the bottom of this slide. So even powers are always non-negative, right? If you look at the graph of like y equals x squared or y equals x to the fourth, it's always going to be at least 0, and most likely bigger than 0. But odd powers like x to the first or x cubed or so on can change sign. And we'll see this is also very important to know this, so that you know whether dy dx is going to be a certain sign in a certain quadrant. So that's the end of this video. Again, in the next video, we will be covering applications of this strategy for multiple choice slope field problems. And thanks for watching, and consider liking and subscribing. Feel free to leave comments or feedback or anything in the comment section below, and I'll see you guys in the next one.